But yeah, what I would like to show you is the contact results. And you have different things, and one thing is gap. Also very good to check if how the gap is. So they are pretty close with 2 to the power of -7, so they are in contact. So that's one thing. Status is definitely one thing to check, because you can also see frozen contacts and the closed slip contact, so you can directly differentiate between those two. Hey guys, welcome to module number 5 of the Inspire course kit. This will be a shorter one, I must say, because Eric did a fantastic job of already doing a video with narrated voice. And I would strongly recommend you to check this out and just see how it goes. The UI didn't change too much from Inspire 2018, I think he used, compared to 2025. But just briefly, I will just show you how it's being done in Inspire 2025, so you see the latest UI. And also I would like to introduce you again to the connector issue or connector thing, and just do a simple load case on the part as well. So connectors. Basically what you have is this file which I load in, which is a drone, and you can see now you have different parts. And basically the first thing what you would like to do is to delete all those geometric representations of the bolts or screws. So I just search for hexagon and just delete all of them. So basically how you do the connector or the fastener thing here is you press on fastening or fastener, and then you can see all the holes it found. And basically what it did not find here is those two holes, because they're too much apart. But just to show you how it's done, just simply select the two and then click on the one which is the first one, and then it will create something like this. And you could also choose between different types of fasteners. Okay, so let's do that for those two, and I think the ones in the middle I will leave there, because that's mounting screws for, I think, like an electric board or something like this. All right, then I can do all the others, and I'm done already. So what else is pretty interesting with the fasteners is preload. And you can choose to have a preload by selecting the fastener, and then you can see here pretension. Preload, pretension, you know what I mean. So it's like when you're tightening the screw, it will have some force, and this force is called the pretension. And to just calculate that, if you want, there are like some tables, and I just measured it. So those are M3 screws. So for example, if I hide one of those holes here, I can then just simply measure. Yeah, see it already, 3 millimeters of diameter. So basically, those are M3 screws. And if you just look into this table, you would see that you have M3 with a 8.8 classification. The preload is around 2.5 kilonewtons, right? Okay, so basically that's how you calculate this, and then you could just simply select the fasteners and then do your preload. I will not do that right now because I'm not 100% sure on those two. So I think all the others with 2.3 kilonewtons should be fine, but I'm more than worried that if you put 2.5 kilonewtons on one of these, they will bend this down completely, right? So I think there should be something like a distance part, like here, in order to have those bolts ready. So I'm not worrying too much about pretension, but what I want to show you here is one thing, the connector issue, and then it will be like a little preview for the next module, which is inertial relief analysis, because a drone like this is a perfect example for inertial relief. Okay, so how to do this is, well, you would like to apply the force in those kind of locations. And the way to do this is, well, one way to do this is to create connectors. And connector on this surface, now you can see it would like to connect to something else, but you can just place this wherever you like with a click. Then choose it to be rigid. Why? We will cover in a minute. But then it's very important that you go on the lower left and click Auto Center. That means the master node, the location of the master node is automatically calculated to be at the center of whatever you selected as a surface or line or whatever. So this would be the thing. And now right click and swipe to the left to complete it. Now here's the trick. If you now click again on connectors, this connector is still selected, and you can see that by this dashed line pointing to this connector. So what you would like to do is, before clicking on the connector again, click somewhere here. Yeah, just click somewhere in the graphical area so you see the connector is deselected, and then you can click on connector and do the next one. So we will do that a couple of times. Do that to rigid, auto calculate, that's all right. Click somewhere. And next one, connector. Yeah, why is this rigid? Why not flexible? The reason why I think rigid is better here is because you are screwing some motor in here. And so I think they will be in contact all around here. And that's why they have the stiffness. And that's why rigid would fit a little bit better, because rigid prevents some motion between slave nodes. So the surface I select here cannot move relative to each other points of the surface. So that's the reason why I think rigid is the more valuable, or what the more fitting solution for here. But it could also be that you have a gap and then it would not be. So depends on how the geometric solution really looks like. And maybe you should also see that it's maybe screwed with those 4 holes here, then it would also be a little bit of a different story. But yeah, just keeping it brief and simple here, we want to see the bending effects on here, and that's what we are interested about. Okay, so I created all the connectors. Now let's create the force, and yeah, so that's pretty simple. I will just select the master node, select some load, let's say just 100 newtons, and pointing in the right direction, that's good. So do that a couple of times. And then with inertial relief, you don't have to have a support defined. Like you would with a static analysis, you would have to hold something in place because otherwise the force would push this drone to infinity. And that's not what we would like, because then you don't have any reactions or stress, because then it's just moving. So you would like to constrain something, but for inertial relief, a solver is taking care of that. More in the next video or the next module about inertial relief. Okay, so we're already done here. The only other thing I would also like to simply show you is the contacts. And the contacts come in different flavors. They can be bonded or sliding. And if you like to get more details about that, please watch the excellent video from Eric. And so I will just go briefly over it. So blue means frozen, that means it cannot move at all. And yellow means sliding, that means it can move relative to each other. And then we have some areas with no contact. That's interesting. I think that should be considered sliding too. Not sure, that's maybe something with the calculation, but you see, it's always good to check your contacts before you do that, or before you do your analysis. Okay, here we also have no contact. I think that's also a mistake. That should be also sliding contacts. Because here you have this this distance part between between the upper and the lower plate, and that's why there should be a contact. So good that we checked that, and you saw how I changed the type of contact. And blue or bonded is correct here, because this is actually one part, but maybe it was being splitted, because this part later should be a design space, for example. Yeah, should be considered for a topology optimization, where the other parts should be the same because of interfaces. Okay, so that's about it. And now we let run the analysis for the inertial relief. How to do this is you select whatever you want, and then with the load cases you have this little checkbox, and it's called use inertial relief. And what this will do, it will calculate the acceleration forces needed to balance out the external forces which you are bringing on this model, and then it will be in a correctly constrained situation and will show you the correct forces for this. More in the next video. So I will run that, pause the video because it takes a little bit, and then show you some contact results because they're also very interesting to check. Alright, simulation is done. Let's check it. So basically what you can see here is the displacement, and let's just simply animate this for better understanding. That makes sense. And it's 0.04 millimeters, so not too much. But I think I went with the default material, which may not be... Yeah, so this is steel right now, so don't take it for granted this will just move this big. But yeah, what I would like to show you is the contact results. And you have different things, and one thing is gap. Also very good to check how the gap is. So they are pretty close with 0.2 to the power of -7, so they are in contact. So that's one thing. Status is definitely one thing to check, because you can also see frozen contacts and the closed slip contact, so you can directly differentiate between those two. And then for sure contact pressure, for example, which will not be too much here because yeah, we don't have a pretension, but if you had pretension this would look different, and also then kind of different contact forces, normal force, tangent and traction forces. So you could check them as well, and they will give you hints on how the contact is working. You definitely see also that the mesh is rather coarse. You could also see that with the mesh button here. So if I would have to design or analyze this part, for sure I would choose a smaller mesh size just to be able to get something from here. But yeah, as a first interpretation, first guessing of the model, I think this works fine. So that's what covers this lecture about assemblies. So I would say it's interesting to check Eric's video, because it goes a lot more into the detail of how to create fasteners or joints, or the difference between those two. Then we saw again the connector issue, or the connectors to apply forces. We briefly also considered inertial relief analysis, which will be the content of the next module. And so this will get you a little bit of a preview for this, because it's just a fitting topic. Drones and inertial relief, they go hand in hand. Alright, if you have any questions or comments about this video, please leave a comment down below, and I hope to see you in the next video. Bye guys!